to web development. So we are now on week 2 out of 2. So we're halfway through. Last week we laid a lot of the foundation for just web development in general. We looked at HTML and CSS and JavaScript all at an introductory level. So the point of this week is to kind of dive a bit deeper into JavaScript. So tonight I'm going to just review everything we did last week, a little review of all 3 of the languages, and then we are going to take a look at JavaScript functions. So as always, I'm Deandra Ryan Moss. I'm your instructor. I'm teaching you guys tonight from a rainy night in Bisbee, Arizona, and I hope you guys are excited to learn about JavaScript wherever you are, out in the country or out in the world. So before we dive into the topics for tonight, I'll take a little look into what you have to look forward to if you join the Lambda School main curriculum. So I've talked a bit every single night about what you could look forward to in the Lambda School main curriculum. And tonight I want to dive a little deeper into, I think, one of the scariest topics for everyone, which is the idea of the hiring process. So what happens once you're through Lambda School and ready to look for a job out in the world? Well, to start, the most important thing when looking for a job in the programming field is that you're actually prepared. So Lambda School's curriculum is designed to prepare you for the job. So we really focus on a lot of practical, modern skills. So what's great about a boot camp versus, or an immersive versus a computer science degree is that because we don't have to deal with all the hierarchy of accreditation and administration, we can teach you what's relevant right now. So we teach you the hands-on skills for web development, such as, of course, the 3 languages we've looked at already. But in addition to that, we teach you relevant frameworks, which are exactly what are needed to build web development or to develop web software out in the world. And to give you guys a little real-world taste of what I'm saying, before I came to Lambda School, I was working an industry job in the software industry, and I was part of the process of us hiring new developers. And I can tell you from my experience that pretty much everyone we interviewed who was coming from a computer science background, even if they seemed really smart and really capable and really reliable, we always came away from those interviews going, they really don't have any experience with the tools and the languages we actually use. Whereas, you know, we would get a variety of people coming out of immersives, some who seemed more knowledgeable than others, but much more generally across the board, we would say, hey, those people actually know how to do the kinds of things we are literally doing in our day-to-day. So immersives are pretty great for that. Beyond just having the skills you need to go out into the industry, you also have an entire team dedicated to helping you get there. So we don't just teach you the coding. We also prepare you for the job search process by helping you build resumes, offering you support, some coaching as far as what you can expect in the interview. And of course, we also have some hiring partners. So in some cases, we can connect you directly with the job. And beyond all of that, we of course don't want you ever to be sitting there worrying, am I going to get the money back that I sunk into this expensive program? Because we have a deferred tuition plan, which means that you do not have to pay your tuition up front. So the way our tuition model works is that you only start paying your tuition after you are hired. So while the job search process can be nerve-wracking and that's a little bit of an inevitable, at least you don't have the added stress of, uh-oh, if I don't get this job, how am I going to pay back this giant tuition bill? Instead, you don't have to worry about starting to pay your tuition until after you are hired. So that's another really great thing about the main curriculum. As always, if you're curious about more questions for admissions or how to get started applying for the program, reach out to Karen Zachary. I know she was on vacation. I think she's back. I should have checked that before, but reach out to her. And if she doesn't get back to you today, she'll get back to you soon. And yeah, so now that you know a little bit more about what you have to look forward to with the main curriculum and the job beyond that, let's get you guys ready. So let's dive a bit deeper into JavaScript, but first we're going to do a little review of CSS and HTML. So I'm going to go ahead and share my screen and we'll do a little HTML, CSS review, a little JavaScript review, and then we will dive into the topic for tonight, which is JavaScript functions. Okay, here we are. So I have pre-populated this CodePen screen with a little bit of HTML and CSS for you guys to review. So up here in the HTML section, I've put a few elements on the page, just some basic things. We have a div container, we have a header, and 3 paragraphs. And notice that I've thrown a couple of IDs and classes. So the ID, which is on this main div, and these 2 classes, child, which are on the top 2 paragraphs, will all be used for styling. But the big takeaway of HTML is that it's the language we use to put content on the screen. So we have, a box to contain the other bits of content. We also have a header that contains text, a couple paragraphs, and with all of these, syntactically, we can see this pattern, which is we have an opening tag, some content, whether it's text or other elements, and then a closing tag. So that's the basics of HTML. Of course, as you've learned, there's a bit more to it, but a little reminder of how that works, and hopefully you guys are not forgetting too much about HTML and playing with it a little bit on the side, though I know JavaScript is a demanding language to learn. And beyond HTML, we have CSS, which of course is kind of the sister language that we use to style our web pages. So the way CSS works is we start by selecting something. In this case, I'm selecting the div, and then I throw on some styles, so some properties and values, things like the margin, padding, border, background color, etc. So we can see all this style that's appearing over here in screen on our div. The code for that exists over here in our CSS. I've also styled my header, made the margin of it a little bigger. We can see that there's that large space below. I've also styled using class and ID selectors. So instead of just selecting all the H1s or all the paragraphs, we can select only a couple of the paragraphs with the child class. So notice that this larger font size, I'll make it even bigger to make it more obvious. This larger font size of 30 only applies to 2 of the paragraphs, but not the 3rd one because it doesn't have this class of child. Similarly, we can also grab the div with the parent ID, and notice that in this case, I've changed the background color to lavender. So if I change this up here to, let's say, red, we would see that, wait a minute. Oh, I think I misspelled lavender. Let's try that again. Cool. So notice that if I change the background color up here in the div to red, that this ID styling would overwrite it. So if this were gone, then that would be that horrible red color. But when I put it back, because there's a priority system, the ID will always be prioritized over a regular just div selector. So there is a little review of HTML and CSS. Don't want to dive into that too deeply because we need plenty of time to focus on JavaScript, but a little reminder of a couple things you learned last week. And of course, all 3 of these languages will really come together once we get to the main curriculum, because you'll have a chance to use all the JavaScript skills you're learning in this introduction course to build websites. So unfortunately, this little JS tag that we have down here, though there's a little bit of JavaScript in there. This thing, we're not really using much of it yet, but it will be something that we can integrate our JavaScript skills into as we move forward and especially get into the main curriculum. So let's go ahead and cut out of CodePen and into Replit. So both of these, as a reminder, are sandbox environments. That means that they're online tools that we can use to write smaller pieces of code and get immediate feedback. Extremely useful things to have under our belt when we're learning languages for the first time. So as you have experienced the last 2 nights of last week, Replit is the tool we will be using all week. So I'll be using it in the lessons and you'll be using it for your homework. So let's go ahead and use Replit to review a couple of the things we learned in JavaScript last week. To start, let me talk about declaring variables. This is kind of the most basic thing we do in JavaScript, but it's so important, so I'm going to keep going over it. There are 2 different ways to declare variables. There are actually 3, but because I advise against var, we won't review it. So we'll just talk about const and let. Both of these are used to create a variable, which means that we store some piece of data in memory, and then we have a variable name that we'll use to access it. The difference between const and let, of course, is that const creates a constant variable. That means that the name we use to refer to the object always must refer to the same object. With let, there's some wiggle room. Let me show you what I mean. If I created a name variable with my name and an age variable with not actually my age, we have two different variables I just created. In both cases, there is some sort of JavaScript object, some sort of data that we create. In the first case, I've created a string. In the second case, I've created a number. And then we've named each of these. And so the name is how we're going to look up that thing in memory. So we're storing something and we're giving ourselves a way of looking it up. So because this first thing I created is a constant variable, that means that this variable name always has to, in fact, I'm going to call this first name. So the term first name will always refer to the string Deandra. It can't ever refer to anything else. So if I tried to store something else in here, like Stephen, we would get an error. Notice it says error on line 4, assignment to a constant variable. That's because by using this keyword, we're saying that this name always must refer to this value, this string. Because I've used let on line 4, the rules are slightly different. So as with the constant variable, we are creating this JavaScript object, in this case a number, and we're storing that number somewhere in memory, and we're saying, let's look up age using, let's look up this value using the word age. So now whenever I look up using age, remember when I just type out a variable name, I'm actually looking up the value, 66 pops up. But because it's not constant, age might refer to something else somewhere later on in the code. So if I reassigned age to 67, that would not throw an error. So those are two ways of declaring variables. You hopefully have a bit of experience with both of them so far, but I just wanted to make sure that those were all squared away, because those are really the building block that everything we do relies on. So those are the two ways to declare variables. Of course, once we've created some variables, there's all sorts of crazy things that we could potentially do with them. What I'm first going to talk about is, or review again, are conditionals. So as we know, there's something called an if and an else statement that we can use in JavaScript for optional blocks of code. So I will use my favorite raining example, since it is in fact raining in Bisbee. So raining is set equal to true. So if it is raining, then I want to wear a rain jacket. So if raining is set equal to 2, this log will, or set equal to true, this log will run. So everything inside of this if block, inside of the 2 curly brackets, will only run if the condition in the parentheses is set equal to true. So right now, that code runs. If I set it equal to false, it'll just skip that block of code. And this thing inside of the curly brackets, this if block, it could be 1 line of code like it is right now, or it could be 100 lines of code. The biggest takeaway is that it is optional. It will only run when the condition is true, or as you saw on Thursday, something like truthy. But we won't really review that because, yeah, we're not going to deal with truthy for the rest of the course. So, or at least for the rest of this week. So you can go ahead and store that one in the back of your mind. But what's more important is to remember that this condition must be true for the if block to run. Sometimes we might want a default bit of code. So the else statement we would only put in if we want a default, something to occur when this condition is false. So we might say console log, take a walk, if it's not raining. I guess we're probably wearing a rain jacket if we're taking a walk. It's all right, it's just an example. So the if block will always run when this is true, and the else block will run if it's false. And I know that one of the hardest things to get down when you're new to JavaScript is the syntax. So I will say that the most important thing you take away from these lectures is the concepts behind the if-else. As far as remembering exactly where the parentheses go or exactly where the curly brackets go, you'll get used to that soon, but for now, just Google an example There's really no harm in looking up an example of an if-else block so that you remember exactly where the syntax goes. I know it's a headache at the beginning to remember how all the parentheses and brackets work together on these languages. So there is that first conditional that we learned on Wednesday and then really dug into on Thursday. The other thing I showed you on Thursday at the end was a loop. So whereas an if-else statement creates optional blocks of code, loops are good when we want the same piece of code to run many times in a row. So the most classic example is going to be some sort of countdown. So, or count, let's do count up. That's even simpler. So if we, let me put together my loop and then I will remind you guys how it works. We're going to be counting up to 10 or up to 9 from 0 because we're programmers, so we start at 0. All right, so I've created a loop that logs from 0 all the way up to 9. So let's go ahead and review how this works. All the details of how we're looping occur in the parentheses. So just like the parentheses contain the condition in the if statement, they contain the conditions for the for loop. And these conditions are all centered around this variable called I. It doesn't need to be called I, but by default, we always call it I. And the I is an index. So the I is telling us, the I is counting our way through the loop. So the I should always refer to a number. It's our way of keeping track of where we are within our loop. Oops, sorry, 1 second. All right. So, okay, sorry about that. So, so the I is our counter. It's our way of keeping track of where we are in our loop. So by default, we would probably just want to start it at 0 and count it up to however many times we're planning on repeating something. So if we're trying to repeat something 10 times, we would start at 0 and go up to 9. As you guys saw in the homework, sometimes you might start at somewhere else. You know, if you were trying to count down or count up in increments of 3, then you might set it up slightly different. But by default, just think about I as being a counter that starts at 0 and then iterates however many times you're going to need to repeat. So let's go over the conditions in detail. This first one is where we declare I, and I've started it at 0. Once again, that should be just your default unless you are trying to count down or do something a little different. So we default setting our I to 0, and we always use let for our I because it's going to be changing, so a constant variable won't work. Then we basically tell it when we want to stop. So because I want to go 10 times, I can just say as long as I is less than 10. So this is some sort of usually comparison where we figure out when we want to stop I or when we want I to continue. So whenever this condition becomes false, our loop will stop looping. And of course, we need some way of incrementing our I. So once again, by default, always think of the third condition as being I++. There are certainly cases where that might be different. If you were trying to increment in 2s, you might do plus equal to, which I bet some of you guys learned about this plus equals operator Googling around on the homework. This is just saying add 2 to I each time, or we could increment by 3, or whatever else we wanted to do. We could also, of course, decrement I, that is loop down, but just make sure that your starting point, your ending point, and whether you're increasing I or decreasing it all kind of line up, or else you might end up with an infinite loop or maybe a loop that doesn't even run. As far as what goes inside the curly brackets, that's what do we want to repeat. And in the examples we did in the homework, we pretty much just stuck with console logs, but just to let you guys know, there are other things we might be doing in a loop. So as far as console logs go, the simplest thing we could do is just log out our index. So that'll just show us how our index is looping through. It's always great to throw a console log I in here just as a starting point because that'll give you some bearings on what's going on with your loop. Beyond logging I, we could always just, if we wanted to log a phrase, if we wanted to log the same thing 10 times, we could do that. So you don't even need to access I within these curly brackets if you don't want to or if you don't need to. Just oftentimes that becomes useful. So I can be something that you actually use inside of the loop, or it can be something that just keeps track of how many times you're going through. So there's a little review of loops for you guys. Both if-else statements and loops are going to come into play again and again throughout this week. So you'll have more practice to get those down if you haven't already. All right, so let's go ahead and move on to the big topic for tonight, which is JavaScript functions. We've seen a few examples of functions so far, mostly in the form of methods. So I'm going to review what methods are and how they work, as well as giving you a little bit of a deeper dive into them. And then we'll discuss the idea of actually writing our own functions. All right, so let me talk about what you've seen so far with methods. So methods are built-in functions. Well, let me define function first. I think about functions as being rule books that exist in JavaScript, or you could think of them also as being smaller scripts. So function is a pre-written script or chunk of code. So it's kind of this pre-written chunk of code that's designed to do something in particular. Like, for example, a pre-written set of rules for how to add a couple numbers together, or how to change a string around, how to reverse a string, or take all the characters in a string and put them to uppercase, as we've seen an example of. Or something like math.random, a pre-written script that generates a random number between 0 and 1. So when we have just a function on its own, something like math.random, think of this as being the rule book. So this is a function. We can tell because when I run it, it just says function over here in green. So a function on its own isn't very interesting. It's kind of like the potential for something to run, but it hasn't actually run. So in order to see what a function really does, we actually need to call it. So there is this distinction between a function and a function call. So the function is the potential for a script to run, whereas a function call is the script actually running. And I added the parentheses over here in my comments to indicate to you guys that you can always tell the difference between a function and a function call because of the parentheses. So think of those parentheses as being a big button that you press when you want to run the function. So notice that when we had just the function on its own, that this bit of code resolves to a function, which is a different JavaScript data type. So we've seen things like strings and numbers. Functions are another type of data we might work with in JavaScript. So, and then math.random, so this on its own is just a function. Not very interesting. With the parentheses, we have a function call. So this line of code can resolve to really anything. I mean, in this case, it resolves to a number. We can see that by running it. But functions can resolve to strings. Excuse me. They can resolve to strings. They can not resolve to anything. They can resolve to other functions. And that's what's called the return value. So another really important concept when discussing functions is this idea of input and output. So we have input versus output. So I'll talk about output first because that's the one I just mentioned. So the output is called the return value. So think of that as the thing that is spit out when the function is called. So that is the result that is given back to you as the user after you call the function. So we know that in the case of math.random, a return value is going to be a number. And to get more specific, it's going to be some random number. Excuse me, sorry. Got something caught in my throat. Sorry about that. So in the case of math.random, the return value is actually going to be, specifically going to be some random number between 0 and 1. And every function has a different type of return value. And when you're talking about built-in functions like methods, if you're curious about the return value, you can always look that up online. It's going to be well documented in the documentation. So let's look at a couple other examples so we could get an idea of return values. We've seen a couple string methods as well. So if I come up with this name variable, and I did name.toUpperCase. So this is also a method, and methods are just built-in functions. So methods are functions that are built into JavaScript. You can usually tell a method because it is always in this dot notation. So we have some sort of variable, dot, and then the method name. So to clarify this method function distinction, all functions, or all methods are functions, but not all functions are methods. And we will see some examples of non-method functions in just a little bit. But right now, let's just work with these methods because they're a little more familiar to you. So name.upperCase is another example of a function. Without the parentheses, we know that this is a function. With the parentheses, it is a function call. So when we're thinking about the return value, we can see that toUpperCase will return a string, and specifically it will return whatever string is over here before the dot, but with all the characters uppercased. So these are a couple examples of return values. As it were, not all functions have a return value. So an example of that might be console log. So this is a confusing example for a lot of people because we think of, well, console log returns whatever is spit out to the console, right? The return value of this would be hey. But that's an important distinction. So hey will appear on the console in white, but it's not the return value. That's just a result that occurs as the function is run. The return value is whatever this line of code actually spits out, which is undefined. You can see that in green. So to confirm the return value of a function, always just call the function on the last line in Replit, and whatever appears in green is going to be a return value. That's what's being spit out. And in some cases, nothing's being spit out, such as with console log. So there you go. That's a little look into return values. But we also have to look at inputs. So what do we put into a function? Well, there's two terms that you have to know to understand the input in a function. Those terms are parameter and argument. So let's talk about both. So these, and I will just say, these are two confusing terms that a lot of people swap. So I am going to teach you the technical meaning of both of them. If you accidentally use them incorrectly, it's okay, it happens. Try to get them straight, but you'll probably catch me using the wrong term. This is like one of those classically confusing things in JavaScript. So parameters. Both of these are all about what you put into a function. So what actually goes into the parentheses. So the parameter is a general term. And I'm going to change this to math.round because I think it's an easier example, round. So we know that math.round, you put a number in and you get out a rounded version of the number. So the parameter for math.round would be a single number. So this is more of a general rule. This is like a high-level general rule of what goes in the function. We know that just you're going to put a number in, and just one. Whereas an argument tells you what goes in a particular case. So the specific number 3.4. So notice that parameter is something we would say when we're just more talking about the function itself. So you would say the function math.round takes in a single number as a parameter. But if we're talking about a specific function call, like the function call on line 10, we would say that the argument in this case is the specific number 3.4. So that is the difference between parameter and argument. Parameter is more of a general rule of what goes in, and an argument is what we specifically put in the function in this specific case. So if we called math.round 3 times with 3 different numbers, we would see that we have 3 different arguments in these 3 different cases. The argument in this case is 3.4, in this case it's 2.1, in this case it's 1.9. But in all 3 cases, we would say the parameter is a number. So that is the difference between a parameter and argument. They're both terms we use to refer to the input. And as we start to write functions, this term parameter becomes a little more meaningful. When we're just calling methods or calling functions, We care more about the argument because that's the specific thing we're putting in the case of that call. So there you go. That's really all the terms that you need to know for talking about functions. And I know it's a little tough to keep these function term or any of these terms straight at the beginning, but I'm going to try to keep using these 3 terms, return value, argument, and parameter, again and again as we go through tonight's lecture to try and really grind them home for you guys. Because it's one thing to understand it, it's another thing to be able to talk about it, and that is one of the challenges of learning something complex like JavaScript, is that you have to, you're like, I get it, I get how it works, but like, I can't remember what word means what and where to put the curly brackets. That's a learning curve that we all have to deal with. So be patient with yourself as you get used to all these new things. Okay, so now that we have kind of a dictionary of function terms, let's go ahead and explore these ideas with a couple more examples of methods that we've seen. So notice that all of these things are optional. So we see that with math.random that I did at the beginning, there's no arguments, there's no parameters expected. So as some of you might have learned by playing around the homework, we can always choose to put arguments in, even if no parameters are expected. And JavaScript is flexible enough that it won't break it. So basically, if we just throw random parameters in, it'll ignore them. So there's no point in doing it, but it'll ignore them. What's cool is that, so math.random expects no arguments, no parameters. Math.round, which we saw just a moment ago, expects 1. But some functions, like console.log, expect an unlimited amount. If you put none in console.log, nothing's going to happen. But you could put 1 argument in, you could put 4 arguments in, and it will adjust. It will actually adjust based on what you put in. So this is something kind of cool about JavaScript that if you're coming from an object-oriented language might blow your mind, is that there's actually a ton of flexibility in what we do with our parameters. So, and kind of the same thing goes with return values. As I already showed you, some functions will have a return value, some won't. It's impossible for there to be more than 1 return value. There's just one thing that can be spit out of a function at once, and you'll see more of that as we start writing our own functions. All right, so there's a little bit of a review of some of the methods that we've seen already with some terminology and a detailed look in place to hopefully give you a better idea of the thing that you've actually been working with already. So things get really interesting when we start to write our own functions. So methods are functions that are pre-written. They're built into the language. So all we have to do is execute them. But sometimes we want to write our own functions. In fact, very often we want to write our own functions. So let me show you how to do that. And I'm going to start with a basic example that just says hi. So what if I wanted a function that just logs out hi to the console? So I think that in my code base, I'm going to be logging hello to the console many times. So instead of having to write out console.log hi every single time, wouldn't it be nice if I could just write say hi? So every time I want to write this piece of code, I can just write this instead. That would be a basic example of when we want to write a function. So let's create the say hi function. Right now, I'm getting reference error. Say hi is not defined. That means we haven't written it yet. So let's go ahead and do that. Okay, so this is the basic syntax for writing a function. So it looks maybe kind of similar to some of the things you've seen already, parentheses and curly brackets. You're gonna get used to them. You're gonna see more of them. So we start out with the function keyword. That's saying we would like to create a function. Then we want to name our function. If we leave out this line of code, we have something called an anonymous function. We're not gonna get into those too much today, but we will see some really useful places where we use anonymous functions later in the week. So for now, we would like to always name our functions. So just like naming a variable, this can be anything as long as it's not a keyword in JavaScript. You want it to be something useful and meaningful, like say hi. Following that, we have a set of parentheses. So right now, these are blank. And that's because this function has 0 parameters. But we'll see an example in just a minute where we have parameters, and you'll see why these parentheses are important. But even if you're writing a function with no parameters, that means no input, you still have to put the parentheses there. Following that, we have curly brackets. And just like with if statements, else statements, loops, we have, and yes, I do know my battery is low. I forgot to plug in my computer at the beginning of the lesson, but I'm pretty sure we have enough life to get through the lecture. So, and the reason I actually always plug in my computer is because every single time I don't, someone is like, your battery's low, it's making me anxious. So I apologize for not plugging it in. That was a total side tangent, but thanks for letting me know. All right, so let's talk about function scope. So we saw with ifs, and we saw with ifs, and we saw with loops and with else's that we have these curly brackets, and those start us off with blocks. And we have something called scope inside of this. So just like with the things we've seen already, we could call this our function scope inside of the curly brackets. And this is where we write our rules. So remember at the beginning that I said that you could think of a function as being a rule book or a pre-written script that you might want to just execute at the drop of a dime later? That's where the actual script goes, is inside of these curly brackets. And as with loops and with if statements, you always want to indent everything that's inside of these curly brackets just to keep your code readable. In this case, our function is super simple. We just want to console log hi. So this console log statement inside our function scope won't run. Notice that when I run this script, we get no console logs. That's because we haven't actually executed our function at any point. We've just created a predefined thing that we can now execute as many times as we want. So let's go ahead and actually execute it. I'm going to call this function several times. Let's just call it twice for now. And the syntax is exactly the same as with a method. To call our new function, you just have to say the function name followed by parentheses. And because we have no arguments, there's nothing that needs to go in these. So when I run this, I get hi logged out twice to the console. What's really cool about this is I can even run it above my function declaration. So this is something called hoisting, not an important term for you to know right now, but if anyone was curious. Hoisting means that the JavaScript compiler actually reads this first, which means that we can run say hi wherever we want, whether it's above or below our function declaration. So there you go. That is the basics of how we write and execute our own functions. Let's look at a couple extra examples that'll give us a little more look into things like arguments, parameters, and return values. So I am now going to create a new function called, let's call this add and log. So this is going to expect 2 numbers. And what we're going to do is we're going to add them up and then log the result. So to start, we want to add these up. So I'm going to call z x plus y. And then we are going to console log our result of z. So something a little more complex is going on in this function because this actually has parameters. So the parameters are going to be x and y. So these are going to be variable names that you come up with to refer to the type of input you expect. So this add and log function expects 2 numbers. So we might expect something like x and y, or maybe number 1 and number 2, just some sort of general useful name to refer to what you expect your user to put in. And what's really cool is that these variable names can be used within the scope of the function. So notice that on line 11, I actually use the input to create a new variable. And then I can log that variable out. So let's go ahead and call our add and log function a couple times to make sure it works. This is also a nice chance to remind you guys about the difference between parameters and arguments. So up here, x and y were parameters. So they were general variable names telling us we expect 2 numbers. Down here in this first function call, we can see arguments. So 4 and 7 are our arguments on this function call. And in this case, 7, and 19. So arguments are going to be the specific numbers we pass in a specific function call. And we can see that the addition result has been logged out in both cases. So we can confirm that our add and log function works as expected. Another thing I want to note with this function is tying in the idea of scope. So scope is this mysterious thing I've been bringing up with all the new tools that you use. So whenever we have curly brackets like this, whether it's a new function or if it's an if block, we always create something called scope. And remember that variables work a little different in scope. So this x and y, these two parameters, these only exist inside of the function scope, as well as any new variables I create below. So if I try to look at x outside of my function, we get x is not defined. If I try to look at y or z, which I declared inside of my function, I get a reference error in every case. That's because of scope. So these variables are only accessible inside of the curly brackets, inside of the function scope. So what happens if we want the result? So we log out the result in this case, but it might be more useful if we actually had the z's spit out. And we know that z isn't accessible as the code stands. So instead of add and log, if we just wanted a regular add function that adds up two numbers and gives you the result, we would need a return statement. So instead of console logging, we're going to change this to a function that actually returns out our value of z. So we've just learned a new keyword, return. And it turns out that the keyword return only makes sense inside of the function scope. So if we tried to use return outside of a function scope, we'd get a syntax error over here. So over here on line 16, we have used return incorrectly. It's only used inside of a function. And it basically says, this is what we want to give you back out. Because of scope, everything we do inside of here is kind of invisible to the rest of the code base. So the return statement is super important. It's our way of actually returning a result outside of the function scope and back into the global scope. So let's take a look at it. If we add up 3 and 4 and just run it, because of replit, we can see the result spit back out, but we could also save it into a new variable. So we could always actually run our function and use the function call to create a new variable and store the return value elsewhere. Now, if we look up results, we can see that 9 is saved in results, so we can use that wherever else we want in our code base. So that's a little deeper look into return values. And what's really nice when you write your code is you can always tell when there's a return value, because you will have to write the word return, the keyword return, in order to have a return value. And another side note about this is I broke this up into 2 lines just to make it really clear to you guys. But honestly, if I were writing this in the real world, I probably wouldn't even bother with a Z. You can just return out an expression like this. So we're able to just return, add these up and return all in one line. Remember, this has to do with this key coding idea that wherever you have x plus y, that's exactly the same as whatever number that results to. So now we've created our add function, which is the most sophisticated function we've seen yet, because it has 2 parameters, 2 bits of input that are expected, as well as a return value, which is the output that we as the user get when we actually call the function. So there's the add function. All right, I'm going to show you, let's do one more example. And I'm going to show you a slightly different way to declare a function. So this one is going to be called getLoud. And it's going to take in a string. Actually, I'll change this to phrase. Going to take in some sort of phrase. And what we want to do to this phrase is we want to make it all uppercase and add some exclamation points on the end. So we might do return phrase.to uppercase, and then let's just concatenate some exclamation points on the end. So I've just done all this logic all on one line. I could break it up if I wanted to, but we're taking this phrase, which is our input, to uppercasing it, and then adding some exclamation points on the end. So let's see how this looks. Now, hey there guys has become the shout version of that. Or I might say, sorry, my battery is so low. And that becomes the shouted version of that. So let's take a look at this new this new function declaration style. This is more in the form of the other variables that you've seen so far. So we use a variable keyword. Generally, you would want to use const with a function. I feel like not using const with a function is a really good way to end up with a bug in your code. So I would really stick with constant when declaring functions. Then you name it. Then you use your equal sign for assignment, and then you actually write out just the anonymous function. Remember, that's the function keyword with any parameters followed by the function scope. So that is the second way to declare functions. They're very similar. A lot of people prefer this way because it's more comfortable. It's more similar to the other ways of declaring variables. The other way is a little shorter. The biggest functional difference between the two is, remember that hoisting thing I showed you, where you could actually call a function above the declaration? Doesn't work with this style. So if you want to write your function at the bottom and then call it above, which is sometimes useful in organizing your code base, make sure you use the other style of declaring the function. So as beyond the function declaration style here, we just have more of the same, where we've gone ahead and manipulated our arguments, our inputs, and then returned some sort of new version of them. So another thing I want to mention, which is kind of cool, is that notice that there are two functions at play here. Phrase.toUpperCase is a function that is actually called inside of the function declaration. And the same was true of the console log. So oftentimes function statements have other function calls nested inside of them. So when you call get loud, some other function call is happening behind the scenes. So there are just a few examples of some of the functions that you might use or write, and you'll have a lot of opportunity to write some more on the homework tonight. So I'm going to go ahead and just let me see what I want to do next. Oh, I want to talk about return values in a little more detail before we wrap up tonight. So return values, as I mentioned before, you can only have one return value. And sometimes you won't have any. So, so as far as what literally happens in here, usually you want to just have one return statement. And something that's important to note is that once this return statement happens, the function is done. It's going to stop executing. So if you wrote something else down here, this will never run. So line 12, well, nothing will run if I don't call my function. So I call my function, and notice that this console log, nothing appears in white on the console here. So this console log never ever ran. That's because it's after the return statement. So your return statement should be the last thing in your function. That's a common mistake, is to be like, why is my console log not working? Check if it's below the return statement. On a similar note, sometimes we might use the return statement on its own to tell the code to return out early. So if we had something like, you might have some sort of error checking, like if there is no phrase, and remember, because of truthiness, if this is missing or blank, then nothing will happen. If no phrase, return. So now, notice that now if I put in, something like, if I leave out my arguments, it'll actually return out. Otherwise, we would have had an error saying that toUpperCase can't be called on undefined. So this is a useful way we might use the return statement to actually not say what to spit out, but actually just to say, we want to quit. We want to be done. So a return statement on its own can be used to just say, hey, exit out of the function. Another cool thing that this example shows us is that even though a function only can have one return value, you might use the keyword return multiple times. So let's look again at that raining example from earlier. We might say, check weather, and pass in a Boolean about if it's raining or not. So we might say, if it's raining, then we want to return bad weather. Otherwise, we might want to return good weather. So if we do weather and pass it true, we get bad weather. But if we pass in false, it returns out good weather. So a couple things to note here. The first is that we've written out two different return statements, but only one is going to run each time. So even though there are literally two return statements in the code, we'd still only have one return value. That return value might be different depending on what we put in. So that is one way that, that's one thing that you'll see when you're using return statements, is sometimes you might have to physically write out the word return more than once, even though in each function call, it'll only return out a single value. Another thing to note is that these cool things like if statements and loops can all be used inside of a function. And in fact, you will have to do that for some of the homework tonight. So when you're writing an if statement inside of a function, make sure you have your tabbing in order. Make sure everything inside of the function is tabbed, and then everything inside of the if block is tabbed. It just makes it really readable. Imagine if instead this looked like this, it would be really hard to tell what in the world is going on in here. So practice good tabbing. Once again, you don't have to memorize exactly how this should look. Just Google an example. That'll help you get your tabbing and your brackets and your syntax all straight at the beginning. And I think there's, in Replit, there might be an auto tabbing option. I should look that up. There might be, there might not be. Sorry, don't know offhand. Yeah, so that is another nice thing to know, is that you can actually put things like if statements and loops inside of your function. Really useful and really necessary for writing sophisticated code. So there you have it. That is the crash course in how to write your own functions. I hope you guys got a deeper look into these functions you've already been using, things like console log or math.random, as well as now knowing how to actually create your own functions. So let me go ahead and show you guys what you'll be working on tonight in the homework, and then I will open up the floor for questions. So the homework for tonight, you just want assignments. Things are maybe starting to get simpler now that we're just narrowing our focus onto topics. We just have a bunch of functions that you guys have to write, and we've kind of set them up for you. So the homework is pretty uniform tonight. Just every single problem is a function that we've written it out, we've named it, we've even declared out your parameters, and then we've given you a description of what it should do. It's your job to type inside of the function scope. So you shouldn't be renaming these, you shouldn't be changing your arguments, just write inside of the function scope. So you'll have to sometimes execute logic, you might have to return something, you might have to console log something, you might have to write an if statement, but all your code should go inside of these function brackets in here. So that is the homework for tonight. You just go down the list and write all these functions. And of course, we have tests in place for you. The one thing I wanted to mention is I'm gonna just pull this last problem here and talk about it for 1 minute. So let me copy it over. So this is a function called getHTMLTag. And so how it works is you take in a tag name, like for example, I might call this with getHTMLTag and pass in a string span. And what I wanna get back out is this string. So I pass in a string with a HTML tag name, and I want it to return out the actual opening and closing tag. So the reason I wanted to mention this is because it gets at something a little deeper and more complex, which is this idea of where languages meet. So this is JavaScript code. You are writing JavaScript code here. You can tell it's JavaScript code because you're using JavaScript keywords and JavaScript syntax, and you're writing in a JavaScript replit. That makes it JavaScript code. But what makes it a little weirder is that we're writing JavaScript code that mimics HTML code. So even though right now we're in JavaScript land, we've just spit back out something that is syntactically valid HTML. And so this is really important to get this idea down. And it's not a simple thing of this idea of almost mocking out something like JavaScript or HTML, or sorry, mocking out HTML or CSS in JavaScript. This is how web pages are built. This is a really key look into the kinds of things you'll be building in the main curriculum, because you need to use JavaScript principles to manipulate things that have to do with HTML and CSS. So don't overcomplicate this example. It is just as simple as taking a string and creating a new string out of it. Just think in terms of strings. But in the back of your mind, remember that using one language to create something that looks like another language is a really key principle for web development. So I just wanted to mention that to give you a little bearings of how to look at this problem. And there's another stretch problem which does something really similar. Well, that is it for the lesson tonight, and that's a little insight into the homework for tonight. I, of course, want to give you guys lots of opportunity to work on that, but as always, there will be a chance for questions right now. So surprisingly, the questions have not been piling up throughout the lesson, so I don't have anything to answer right now, but feel free to ask away. So we have a kind of high-level question about, are the hiring partners only in San Francisco? Unfortunately, I do not know the answer to that. You would want to reach out to Karen to get a better answer to that, though perhaps I'll ask her that as well, because that's just a good thing to know. My guess is that probably not. I would think that because it's an online school, we have partners around, but it's probably most heavily concentrated in San Francisco. So that is my guess, but to confirm that, definitely ask Karen. Okay, we have a question about semicolons and functions. So do we need a semicolon at the end of the function? So short answer is no. The brackets will indicate that the function is completed. I like to put semicolons at the end of functions when I'm declaring them using the keyword, but that's my own preference. You might have, there might be, like if you're on a if you get hired, when you get hired, your code team will have specific style guides. So whenever you're on a professional code base, they give you a style guide, or at least hopefully they should. Some don't. But yeah, so the short answer is no, it's not required. You would never get an error for leaving it off, but sometimes you might see them. Okay, we have a request to, oh, now I'm getting a lot of questions. Okay, so we have a question about the different styles of declaring functions and a request to go over that again. So yes, I will do a side-by-side comparison for you guys. So let's do this add function. So I'm just gonna type it out real quick, and then we'll talk about the differences. Versus, oops. Okay, so really similar, but let's talk about the differences. So in the first version, you start with the function keyword, followed by add, followed by the name of the function, and then you have your parentheses where you specify your parameters, followed by the curly brackets where you have the actual content of the function. So that is the first way to declare a function. And remember, that will be hoisted, which means you could use add above where you wrote it. And notice that in this version, I think the biggest things to keep in mind is there's no equal sign, there's no assignment, there is no variable keyword, so no const, no let, and the keyword function comes first. Versus this one where this looks more like if you were to just create a string or a number. You start with your keyword, const, then you use the name of the function, then you use the equal sign for assignment, followed by the name of the function. And then beyond that, it looks exactly the same. You still need your parentheses with the arguments, or sorry, the parameters. See, I'm mixing them up, followed by the curly brackets. So the inside of the function scope, what's written in the curly brackets should look exactly the same. The parameters should look exactly the same. The difference happens before that. In the first case, you have function, followed by the name of the function. In this case, you would use const, name, equals, keyword function. So Don't need to memorize it. Just look it up. It's easy to look up, but good to know. Okay, let's see what else we have. Sorry, just looking down the list. So as far as use cases for those two different function declaration styles, my personal experience is that the use cases, it really depends on code style for the code base you're on, and it also depends on if you need it to be hoisted. Those are the only examples I can think of different uses. There's probably some other stuff that I'm not thinking of, but for the most part, I would just say, just practice using both. Okay, let's say. Sorry, going down my list of questions. All right, so we have a question about prototype remove class. So we are not going to be talking about classes or prototypes until Wednesday, I believe. So I'm going to unfortunately shuffle off your question for right now. If you're a little ahead and you're curious about it, feel free to direct message me on Slack and we can talk a little bit about it. But I don't want to introduce material before the time is right for everyone else. So I will kind of avoid that question. We have a question about elaborating on the add and log function. So let me go ahead and write that one out for you guys. So, and I will compare the add versus the add and log. So I will say that the add function is about, oops, uh-oh. Sorry, that was supposed to be a comma, by the way, I apologize. There we go. So the add function is infinitely better than the add and log function. Honestly, this function is kind of useless. It's just a good example to get you guys started. This function is a lot better because there's a return value, which means you could do whatever you wanted with the added up value. You could store it somewhere, you could log it if you wanted. This has a ton of flexibility. We really like functions with return values. While there are some functions that don't have return values, in most cases, we probably want a return value. So add and log is a little more strict because it adds the numbers together, but then it logs them out. So let's show you how we could use them. So if we used add, in Replit, we can, oops, see, I can tell it's getting to the end of the night. I'm starting to do silly things. Okay, so if we run add, we of course in just Replit can see, okay, the value has been appeared in green. But that kind of minimizes how sophisticated a return value is. Because the real power in this is that we can actually spit the result out into a new variable such as z, and then we could use that result anywhere we wanted in the code base. So the add function is really powerful because it has a return value. Add and log is a little more lame. So add and log will make the result appear over here on the console in white, which might be good if we're debugging, but really doesn't serve us in any other case. So if we tried to store the results, it wouldn't work. I've tried to store the result of this, but the result is actually undefined because add and log does not give you a result. So that's the difference between add versus add and log. I would say this is the kind of function you would actually write and use. There might be some case where you wanted to use this, but this is works better as an example than it does as an actual useful function. So we have a question if add was previously a function or if I created it from scratch. Yep, so I created add from scratch. Honestly, add isn't that useful of a function either because to add x and y is actually more code than to just write x plus y. But think about it this way. Behind the scenes, because add is such a common thing we do in JavaScript, there's actually a shorthand for it. But if we had some more complex function, like, let's say, just going to call this complex function, and maybe we have x, y, and z, and we want to take x plus y and divide it by z, and then take that all to the power of 2. We could do that and then return it. This really would be a useful bit of code to write, because it would be a pain in the butt if we, for some reason, if we needed to combine these 3 numbers in this way a lot in our code base, it would be a total hassle to have to write out math.pow x plus y divided by z to the power of 2 every time we needed to. So now this would be really useful because we could easily execute it every time we need to execute this rule on these 3 numbers. So some of these simple examples are nice for learning, but are kind of maybe don't even save time because the code inside the function is so short. But when you start to have longer chunks of code that you want to run again and again, functions are critical. So yes, to answer the original question, I did create add from scratch. It's not built into JavaScript, at least not that I know of, because it's just so easy to add using the plus sign. But it's good to recognize that whenever you see this function keyword written out, that means we're creating a function from scratch. All right, any other questions? Well, you guys have gone quiet, which either means that it's making sense or your brain has totally melted. I'll assume it's the first one. Okay, so that's all I've got for you guys tonight. Let me get out of the screen share. Okay, well, you guys have plenty of time for your homework tonight. Good luck writing your own custom functions. And of course, stick around for the stand-up at the end. It's really useful to touch base with your classmates and get an idea of where people are at, help people get unstuck with the knowledge you have, help other people help you. So stick around at the end, and I will see you guys tomorrow. Let's see, tomorrow we are talking about objects and arrays. Really fun class. Super useful tool that will totally expand the way that you can use JavaScript. So I will see you guys tomorrow, and good luck with the homework. Have a great night.